Let's find the equation of the plane through the points A, B, and C. We'll start by drawing a representative sketch of our points A, B, and C. And let's draw in the vector AB and AC. So there we go, there are two vectors. Now if we were to take the cross product of these two vectors, we would find a third vector that is perpendicular to both AB and AC. So in our sketch here it's going to look like this. Because of the right-hand rule, we know that this cross product will be pointing downwards here in this sketch. Now the idea is that this cross product that we've just found is a normal vector for the plane. So I'm going to draw another sketch to represent this. Another representative sketch of our points A, B, and C. So here are two vectors. Let's identify the plane that these guys lie in. So there we have our plane. And here again is our vector that is a normal vector for this plane. So let's call that N just to represent the idea that it's a normal vector. Let's label our points A, B, and C on here. And let's point out that that normal vector is AB cross AC. So what we'll do is we'll calculate AB cross AC. Once we've got that, then we'll be able to use the normal form to find the equation of the plane. All right, so let's start our calculation. AB is the vector that we get if algebraically we go B minus A. So that will give us 1, -7, 2. And AC is the vector that we get if we go C minus A. So that will give us 3, -6, -4. Now to calculate the cross product, typically what we do over on the side is we just copy out our first vector. Well, we copy out the components of our first vector, 1, -7, 2. Underneath that we write the components of our second vector, so 3, -6, -4. And I'm just going to recopy the first two columns. So there's our first column recopied and our second column recopied. All right, now the operation we're going to do is we're going to take this product here, -7 times -4, and we're going to go this product minus this backwards product here. So -7 times -4 minus 2 times -6. I would just say to myself, 28 minus -12 gives us 40. So first component of our cross product is 40. Then we go 6 minus -4 gives us positive 10. And -6 minus -21 gives us 15. So that is our cross product. Let's call that AB cross AC. So N is equal to 40, 10, 15, and we can plug into the normal form for a plane. So normal form, n dot x equals n dot p, where p here represents the vector version of any point on the plane. So when we're plugging in here, we could use the point A, we could use a point B, we could use a point C. Any point on that plane will lead to the same answer, the same equation for the plane. So let's plug in. Our normal vector is 40, 10, 15. We're going to dot that with the vector x, which contains our variables x, y, z. And over on the right side, we've got 40, 10, 15 dotted with the vector version of any point on this plane. So let's say we use the point A, 1, 6, 1, for example, and then we'll expand out the dot product. So dot product on the left side, we've got 40 times x plus 10 times y plus 15 times z. Dot product on the right side, 40 times 1 plus 10 times 6 plus 15 times 1 gives us 120. and 15. So this right here, that is a great final answer. That is the equation of the plane through these 3 points. You might notice all your coefficients here are divisible by 5, so you could equally well say 8x plus 2y plus 3z equals 23 if you prefer to make the numbers a little bit smaller. As a double check, you could check that each of these 3 points, A, B, and C, satisfy this equation. So I'm just going to write 3 check marks here to illustrate that we've done that check and that we're satisfied with our final answer.